This is question 2 from the week 9 probability and stats quiz, and in this one we're given a sample size, a random sample size of n equals 60, so quite a large sample, from a non-normal population with a mean, mu and standard deviation sigma, but sigma is unknown, and we're going to conduct a t-test of the hypothesis given here. Well, this is actually irrelevant here because we're asked to calculate the test statistic, the critical value of this test statistic for an alpha size of 0.05. So we know that since we don't know sigma, we don't know the population standard deviation, we're going to need to use a t-test because it's a non-normal population. If it was a normal population with a sample size greater than 30, then it would be okay. But because we've got a non-normal population, you have to use a t-test where sigma is unknown. I hope I got that right. But basically in this case we're going to be looking for a t-test with degrees of freedom equal to 60 minus 1, which is 59. So if you went and looked this up in the textbook, you'd actually come up with the wrong answer because the t-table only goes up to 29 and then says it's the same as the z because it's actually very, very close. But if you go and look this up in online somewhere, you find a t-distribution table that has degrees of freedom up to 60 and even higher. You'll find that the critical value with a one-sided hypothesis test, so it's one-sided, with a one-sided value in the top, you'll find that it's actually 1.671. And because we're looking at, well, I guess the only relevant thing here is the hypothesis 1, or the alternate hypothesis was it was going to be greater than 70, so this is going to be from 1.671 to infinity, and that is the answer. So I hope that makes sense. If you look this up in the normal tables book, you'll get the wrong answer, so you had to use the online calculator or an online calculator, or find another picture online or another source of a t-table somewhere that goes up to 59 degrees of freedom. And once again, my understanding is that for a non-normal population, you can never use a z-test. For a non-normal population, it'll be approximated by a z-test with a very high n, but you can't use that. If we have a normal population, then we're able to use a z-test for a relatively high n value, but for the low n values, we still end up using the t-test.